All right, in this last video, we're just gonna check out the last four polynomials in question number 4 on the worksheet. So starting with O here, we have x squared plus 4. Okay, so now here, notice this is not a difference of squares. So unfortunately, I can't just apply the difference of squares pattern. Okay, so I could, like we did, that was part I, we could consider this as a trinomial. It's x squared plus 0x plus 4. And then I can go ahead and just attempt to factor this as a product of two binomials. Now I need an x and an x. And then for the 4, I'm going to need what? Well, two numbers that multiply to 4. So 1 and 4, 2 and 2. And then for the middle term, that's a 0x, so I'm going to need, right, the two terms when I combine them to cancel out and give me a 0. But see, here's a little bit of a snag. Since the sign of the 4 is a positive, right, the numbers I'm going to put in the binomials, they have to have the same sign. I can't multiply a positive and a negative and get a positive 4 out of that, right? And as you give that some thought, right, you can see, oh, okay, the 1 and 4 can't work because there's no way I can combine a 1 and a 4 and get a 0 out of that. Now the 2 and the 2, I could combine a 2 and a negative 2 and they would cancel out, but see, they're not going to multiply to that positive 4. So this is not going to work, but see, this is not going to work either, right? No matter how I try it, right? Because it's going to have to be a plus or a minus, and see if you try say a plus 2, nope, you're not going to get that middle term of 0x anymore because you get a 2x plus a 2x, and that is just simply not going to work. So what that all is boiling down to here is that this thing simply doesn't factor. Okay, so that's it. Now there is a term for this. If you think back to just factoring, say, whole numbers, like a number like 6, we can write that as 2 times 3, okay? And so in that sense, 6 factors, right? Now a number like 7, right? Well, you can't break up 7 as the product of two whole numbers that are both smaller than 7, right? You can only write it as 7 times 1. And so for that reason, we would call 7 a prime number. And in this context with polynomials that don't factor like this, we would call this a prime polynomial, okay? Okay, cool. Moving on then to P, well, another trinomial, so we can just approach this in the usual way. An x squared, I would need an x and an x. Now for the 1, there's really just one option, right? It's just a 1 and a 1. So if I try a 1 and a 1, the question now is there any way I can combine my inside and outside terms? 1 times x is just x, and x times 1 is also x. And see, here's the snag, right? No matter how I assign positives or negatives, I'm never going to get this middle term of negative x to come out, right? I'm either going to get, because this is a positive 1, they have to have the same sign, I'm either going to get a 2x or a 0, right? So this simply cannot equal negative x. And so for this reason, we have a non-factorable polynomial again. This thing doesn't factor. So again, it's prime. It's a prime polynomial. All right, so that happens sometimes. Now moving on to Q, okay, so first thing that stands out to me here is that I have a difference and there's a square in there. So I'm kind of thinking something along the lines of difference of squares. However, 2 is not a perfect square, right? So that might seem like a roadblock. However, notice also 2 and 50 share a factor of 2. So what I'm going to do to start is just factor that out, and that's going to leave us with x squared minus 25. And hey, 25 is a perfect square, right? I can think about that inside the parentheses expression that's really x squared minus 5 squared. So the idea now is, let's apply the difference of squares pattern to this thing. Okay, so that's going to break down as, well, a minus b, so that'd be x minus 5, times a plus b, it'd be x plus 5. And that 2 is still multiplying that whole thing. And there we have it. So difference of squares patterns coming to the rescue, but we did have to factor that common 2 out to begin. And then finally r. Okay, now here notice this is a 4th power, so you might not be thinking difference of squares. However, 16 is a perfect square, right? It's 4 squared. And it might not jump out to you immediately, but right, x to the 4th really is also a perfect square, right? I can think of this as x squared squared minus 4 squared. Kind of tricky, but that is a difference of squares now. So let's go ahead and factor that down. That would be x squared minus 4. That'd be my a minus b times x squared plus 4. Cool, okay. So am I done? Well, not quite. Why? Because look at this right here now. Is this factorable? And the answer there is, well, yeah, actually it's a difference of squares itself, right? This is x squared minus 2 squared, okay? So we can break that thing down as x minus 2 times x plus 2. So this product right here is the x squared minus 4. Now I still have my x squared plus 4. Just carrying that down. Can I factor it? Okay, well here for the x squared plus 4, notice, oh, that was part O. And what do we find? We found that that thing could not be broken down any further, right? It was a prime polynomial. So here, I actually can't do anything further. So in fact, we are done now, right? So we've applied the difference of squares pattern twice, so a little tricky there, but that's going to do it. All right, cool. Now the last note here I want to say is the following, okay? On your WebAssign homework, you'll notice at the very bottom, I put factoring practice, and then I say not due, just for practice, okay? So this is not a homework assignment, okay? You can totally ignore this if you want, if you feel pretty confident with factoring. But if you do, go ahead and say open it up. Then what you're going to find is just a long list. It's like 28 to 30. Sorry, it's taking a little bit to load. And also there's one of our the publisher videos if you're interested in watching that for more examples or practice. But yeah, just tons and tons and tons of examples. I think there's like 28 total examples. So if you're looking for more practice here, certainly by all means do as much of that as you want. It's a really good review of everything that we've just been talking about, okay? And then the last thing I will say, and then I will shut up, is that I've been factoring in a particular way. Now I know there are lots and lots of different presentations for factoring. There's what's called the factor by grouping method. There's the what's known as sometimes the Vietnamese factoring method. I don't know if people use that very frequently, but I've seen some students doing it. That's fine. There's what's called the box method. Okay, all of those methods are perfectly fine for you to use. So if you have a method that might look visually different than what I've presented here, it does not mean that you have to do what I'm doing here. Okay, you can just stick with the method that you prefer. All right, great. We are going to start Chapter 12 in earnest in the next video with Section 12.1. I will see you there.